Hey, how you doing? You're coding with Paris. It's me, Paris, software engineer. And in the previous video, we talked about object orientation and how it would take your code to the next level. Now, we've also talked about object orientation being a vast subject, but how we could quickly learn it by understanding three concepts, which are classes, inheritance, and polymorphism. In my opinion, that is all you need to quickly understand what object-oriented programming is all about. In this video, we're going to start with our classes. What are classes? Well, I think in order to understand classes, we need to jump back a few steps and describe object orientation really quick, okay? So a long time ago, the beginning of this tutorial, we discussed the fundamental elements of probably every single program that exists. And those things are state and behavior. We refer to them as variables and functions because every single program needs to track state and needs to do some behavior. We took those pieces in this tutorial and we were actually able to create working programs, right? We were able to take those variables and we were able to take those functions, make some code that runs from top to bottom, maybe does some looping, maybe does some branching, and you can do pretty much all you need to do to get a working program with just those elements. But folks, if you just think about those elements, that's like 2D thinking. Meaning if you were to just focus on those things, you can compare your code to like drawing a triangle on a piece of paper. What takes us from drawing triangles on sheets of paper, and I'm referring to code that is functional in the real world, to making 3D pyramids, is another concept that we started talking about, which is objects. Remember, objects are a way for us to group together state and behavior into logical groups. So that would be variables and functions, right? And those objects take our code to that next level and allows us to start thinking about how we can build reusable things, how we can start organizing things. Also, it helps us become more productive because our code can now become our Lego blocks, which we can use to plug and play in many different ways, many different configurations to make a whole shape, or in other words, to make a whole product or suite of products and functionality. That's next level thinking, and that's where I need you to be. If I were to shorten that definition, I would say object orientation is a way to help you start thinking about functionality in terms of productivity, reusability, and understandability of your code. Now, where do classes come into play? When most people start talking about objects, they usually are talking about classes. In classes, let's just say the concept of classes revolve around objects, but they're a little more focused on reusability. Think of classes as blueprints of objects that you want to create. And most programming language has this concept, and what these blueprints allow you to do is to basically design and describe variables and the functions inside these objects. And then you can take these blueprints and actually quickly spin up versions or instances of these objects on the fly in your program, okay? So think of it as a design that the computer language allows you to stamp out, kind of like a factory. So many modern languages have the concept of these blueprints and classes, and you can use them all over the place. The beauty in this is that instead of recreating an object from scratch in your program, kind of like we were doing before in previous examples, what you could do is describe that object once, and then in the program you can just call the constructor. We'll talk about what that is, but you can call the constructor and stamp out an instance of that object. Kind of like how you could take the blueprints of a house and you can rebuild that house many times, but you have designed that house and the way that house looks and feels and behaves. Let's talk about like an example of a car. You can create a car object and add properties to it on the fly, like so, which is pretty much what we did. We created this car object from scratch. And if you were just using objects themselves, you can create these car objects all over the place, but every time you create it, you have to create the car, then you have to add 4 wheels, and then you have to add a function called this. So basically you're creating the object, setting all the properties and the functionality in the object at that time. Whereas if you use a concept called classes, you can reuse the first definition that you created, this blueprint, and say create a car, and you get all of this behavior and state out of a box that you can use throughout your code. It's pretty magical, folks. Okay, so now let's start diving into what classes look like. So like always, what I would suggest with any tutorial that you're watching, whether it's mine or anyone else's, if you want to retain the information, you need to follow along with the examples. So whenever you get the chance, open your editor and follow along. So let's go to our coding with pairs folder and highlight the entire folder here if you're in code and create a new folder. We'll call that folder lesson 7. And inside of that folder, what we can do is create a file that's called class example.js. Don't forget the JS extension. So one of the first things that I want to do is to paste our car objects from our previous slide example. To talk through those with you. As you can remember from previous tutorials, objects look like this in JavaScript. Typically, you have an open and close curly brace, and inside of there, you have properties, and beside the colons here, you have the actual property value. Okay, so when you create objects in JavaScript, this is what they look like. So let's go down to our terminal quick and programmatically call and look inside these objects. So what we can do, if you haven't done it yet, is go to your terminal up top, select new terminal, and you'll get something like this here. What we can do is print the working directory. Make sure you're in the coding with pairs folder by going to cd lesson 7. And then what we'll do is we'll go down here and we'll say console.log, and we'll just say car example 2 really quickly at semicolon, and use node and tell it to run the class example. I didn't type it all the way. I typed part of it and hit tab, hit enter. And what that should do is that should print out that class object here programmatically down in the terminal. You'll see this function. It's just a little description of a function. So this is what the object is established as, and in the program we can do things with this object, including calling this function. So this is the basic setup of an object. However, remember, in order to use this object the way it stands, I would have to recreate this object using this format here every time I needed to create one, like here in car example 2 and car example 3. You can see it becomes a little repetitive, and frankly, it's not easily reusable. So let's talk about classes, and along with that, give an example of what classes look like in JavaScript. So in order to establish what's called a class in JavaScript is we use a keyword called class, and following that keyword, you actually put the name of your class here. So we're going to do a car class this time, and then we have the curly braces. So that lets JavaScript know that you want to create a class or a blueprint. And inside of that blueprint, there are several different pieces you can create that actually helps you establish the aspects, the state and behavior of a car object at the creation of that object, okay? So the first one we're going to attack here is going to be called instance variables. So as you can remember, up above here in our car object, we have these properties, and these properties have values in them. Those can be established in your objects as instance variables the following way. So we can do make, and we can set the make property equal to something. In this case, we're going to do a Chevy. And then we can do another one called model, and we'll make that Camaro. Let's do the ZL1 edition. And then down below that, we can do wheels. And let's do 20-inch wheels and make them black matte. Finally, we're going to do color. And we'll just make this color equal to black. So not only in JavaScript, but with all objects, your instance variables are where you keep state for your object. In this case, we're going to go ahead and say that every time we create a car, it's going to have these properties. So what do we do with this car object now that we've created it? And we'll come back to why there are certain situations why you may not want to go ahead and pre-establish the state. You might want to dynamically establish the state. But anyway, what do you do with this blueprint? How do you use this blueprint? Well, most languages allow you to use the blueprint by using the keyword new. And what I mean by that is I can go below this class and I can say, let's say let car, we already have a car 3. So let's do let car object 1 equal new car, and we'll just do that. And we'll talk about what that means in a second. And then we'll do console.log car object. And then what we'll do is we'll go down to our console and we'll say node run this class and go ahead and print out what's going on here. Maybe I'll go ahead and comment that out so we don't print that and run this example. So you'll see the car object is actually what's being printed here. It says it's a car object, and we know it's a car object because it has this capital CAR in front of it, which is this here. And then inside of the braces, you see this object with the state. Okay. So I can use this and create let car object 2 equals new car. I gotta go down here and say console.log car object 2. Come down here and clear my console. Clear. And now when I run this, it should print it twice. And I can do that for, I can say car object, let's say car object 3 equal new car again. And then console.log car object 3. Let's clear this and run the program again. You'll see it's printed 3 times. So because I've created this class car object, you'll see all 3 instances of the car object were created just by calling the new keyword and setting it to that variable and then logging out that variable. So as you can see, the utility of this is that I don't have to recreate the model or recreate the pieces of the class. Now, something to consider when you're creating classes is that you may not necessarily want to pre-establish these values right away, but you may want to dynamically establish these values. And that's something you can do with another important piece of classes called constructors. So a constructor for a class, I'm just going to take a copy of this and we're going to say, let's say better car class. And what I'm going to do here is I'm going to actually set all these properties to nothing, right? Undefined. So I'm letting my object know that I do want these properties, but I'm not going to set them to anything initially. I'm just going to say these are undefined. Okay, and I can also use null here. We're going to talk about the constructor. Languages do these in different ways. So we have the constructor of the class, and the constructor is a function, and the constructor is the first piece of code that is ran at the establishment of the object. And the importance of this is the constructor may contain, let's call it extra instructions, or extra instructions to run when creating the object. So in this case, instead of pre-establishing these properties the way I did up here in our first object, in our better object, what I can do is I can come down here and I can say this dot make, and that this keyword here is referring to the actual object itself at the time of being created. So I can set this equal to Chevy and do this dot model equals Camaro. I can go down and I can say this dot wheels equal to 20-inch black matte, and I can say this dot color, which is going to be black. So these are now statements, and they are setting these variables. You can see in the constructor that this is being created instead of all being predefined here. And let's go ahead and log. Let's create a better class. Okay, so I can say console.log. Let's just say new better class braces. Come down here, clear this, and I will also go up and comment out the previous logs just to keep our logging clean and help us keep straight what's going on. And let's go ahead and run node example.js. And as you can see here, the better class is now showing up, and inside that better class, you see the properties of that better class here. Now, wait a minute. Isn't this the same thing as doing this? Yes, it is the same thing as doing this. So let's make it even better, okay? So instead of setting it here this way, what I can do is do an even better car class. Hold on. Let's do a best car class. How about that? So let's highlight this. We'll make one more copy of this. And I know this is long, but just keep up with me, okay? And we'll go ahead and comment out this because that's going to be in a way. And let's create the best car class. And I think we're going to continue to edit on this one. And instead of setting the state right away, let's dynamically set the state. So do you remember that this constructor is the first thing that is ran, and it has extra instructions? In this case, this one is just setting all the values at the establishment of the object. Well, we can also tell this constructor to run other functions. Another cool thing we can tell the constructor to do is to actually take in input variables and do things with them. So, for example, I can tell this instructor to take make property, input property, model, input property, wheels, input property, color, input property. And input properties are things that you pass into functions. If any of that confuses you, go back to our tutorial on functions and that will break that down for you. But anyway, I can actually tell the class to use the make. Instead of this pre-canned text in here, I can say use the make property that I pass in, use the model property that I passed in, use the wheels property, and finally use the color. And now when I tell a console.log the new best car class, and I do the open and curly parentheses, instead of leaving them blank, and you can, as you can see, Visual Studio Code already knows about this class because it's reading the class and telling me I can dynamically pass in make, model, wheels, color. Now there are some plugins and things running for this editor, and this editor knows how to guess types, but since I didn't establish a type for any of these objects, it can be of anything. The way this is set up today, it can be of any type, number, string, array, whatever. It's telling me, it's putting any in here, just trying to give me clues that it can be anything that I can put in these. So that's what you're seeing here. Anyway, let's go ahead and put in Chevy, Camaro, ZL1 edition, because that's the best, 20-inch matte, and let's give a color of black. Okay. We'll get rid of the extra param. We'll go ahead and make sure that nothing else is logging here. We'll clear our terminal and then tell Node to run this. And as you can see, now we have the best car class, and that best car class has dynamically set up things just based off of what we enter here. And to nail that home, I can actually tell it to print again. Okay, so let's go down to our terminal and run that, and you'll see now at the establishment of the new class called the best car class, I just pass in parameters, and you'll see I have an object and some state. That's awesome, right? Now you can start to see the utility and the reusability of classes starting to unfold here. A couple of things to note about classes is that your classes in JavaScript usually have to be established above, just like your variables. They have to be predefined before you can start using them down below. So keep that in mind. If I were to take this best class here and put it below here before the establishment of this, now my editor might try to be smart here and help me out, but let's just see if I try to run this now, it'll say it doesn't know what best car class is, right? It doesn't know what it is. So remember, just like with everything else in JavaScript, it runs from top to bottom. You have to establish your class first. So we've talked about the first two pieces of classes. Remember, those would be the instance variables and the constructor. Now we're going to talk about the last piece, at least what is commonly shared across all the programming languages. That last piece is something that you may have seen before. If we scroll back up to the earlier definition, you see that we have a function. Well, from a class standpoint, when you see something that looks like a function, a lot of people also refer to that as a method, okay? And just think about a method as some action that the class can perform. A class can have any number of methods. We have the one up above that is called go beep. Every car class can go beep and basically console.log. And this one, we're just going to tell the car to go beep beep. Silly, but it's just basically a way for us to have the class do action. Now, if we go down below and create a new class quick, so comment these two lines out, and then go down below, and this time we're going to create a variable, and we're going to call that let Camaro equals new best car class. And we're just going to pass in all the variables that we have here because I just want to be annoying like that. This here, we're going to have our computer tell the car to run this method here. Camaro.goBeep. And of course, whenever you call a function, whether it's in a class or not, you have to put open and close paren to let the computer know that you actually want to perform that method. And let's go ahead down to our terminal. We'll clear it. And we'll run that program again. You'll see that the console logs beep beep. Who knows what that is, but beep beep is what I want you to see here. So the class can have any number of methods. These methods can do lots of things. You might find when you're looking at some programs that some folks have methods specifically to set and get properties because certain properties are private. You know, this is a good segue into something that's also very important in object-oriented programming, which is a term called encapsulation. Encapsulation explains that there might be some things inside of classes and objects that you don't really want folks who are reusing this class to actually need to know or even care about. From a coding standpoint, it might be some code, like if this was a class that does complex calculations for an accounting software, there might be some calculation that someone reusing this class might not even need to care about. Maybe it's something that you've patented or whatever. Basically, you're saying that you want that user of the class to be able to call that function, to use that function, but not care how it's done. Let's give an example here in this class real quick to kind of demonstrate what I'm talking about. So let's say besides this simple go beep function, which now every best car class is going to have, we had something else too called get turbo. Totally made up function. But let's pretend that we want everyone to be able to call this function called get turbo. So let's just say to begin with that we have this car called get turbo. And this drive-in, you can go vroom vroom. So again, we can come down here and tell the console to log. And we'll just say, instead of just go beep, we're going to say console.log, and we're going to say get turbo. Camaro.get turbo, and open the curly parentheses. We'll go down here and we'll run that, okay? So you'll see that the console prints out vroom vroom. This is very simple, but this is what we will refer to as a public method because we want what's exposed, which is the function that people are going to call to, you know, if anyone else were to use this car class in their program, we want them to be able to just simply call get turbo and for some magic to happen. But let's say we actually have a really complex, really complicated turbo system that someone is going to buy from you and they don't give a crap how it works. They just want it to work, right? We can use something called encapsulation in our class to denote that we want a class to have some private property. So let's say we have a calculation that does some complex fuel injection, and that is something that you want to put inside of your car. What you can do, we're just going to create a function right below that called complex NO2 injection, okay? And inside of this function, we're not going to pass anything in. Maybe in here we can say some complex ration of NO, or distribution of NO2 injection into the engine, And down below, now we're gonna have this method print. I'm just gonna cut this out of here and then have this method do something. And we'll add some exclamation points to here. Now we're telling this method to call another method inside the class, a function that we're saying is private because we are not going to expose the calculation. For nitrous oxide and O2, and we'll just call that here. So we'll say this dot complex injection. Okay, so we'll come down here and we'll call this function here, again, this get turbo function with our console.log get turbo. And now what it does is it does this complex calculation. Now the person using this class, the only thing they have to care about is this. They don't have to care about this, and it does what it needs to do. Why do we care about private functions or private properties as well? Like, let's say someone might want to have a private function or a private property that really we don't want people to have access to. We might also denote that as underscore private, property. I don't know. I'll think of an example in a second. Why do we care about encapsulation and keeping some things private rather than some things public? Well, again, if we think about a car example, if you buy a car and you're using a car, then you don't necessarily want to know how the engine works in order to use the car. In fact, if everyone had to understand how the engine works in order to use a car, then no one would drive. Think about that from a coding standpoint. If someone wanted to use my better class that I created, this awesome car class that I've created, if they wanted to use it in their code, or if I wanted to use it in other places, some things about this class I don't want people to actually have to think about, right? Things like complex fuel injections or things like that. I just want people to take advantage of the fact that this class that I created now has a cool turbo, and they can just call it by calling the get turbo function. Again, object-oriented programming is all about reusability, and when you're thinking about this in even other languages that have a concept of making private and public methods, or they have a concept of encapsulation, that's the idea that they're trying to get across. I won't spend a lot of time talking about encapsulation because I know that it can be a pretty interesting subject depending on your language. Just think about this. Whenever you create a class, some things are going to be private, and there's a way for each language to try to make that possible. In languages like JavaScript, we have an underscore just denoting that things are private. Some languages like Java, you might actually be able to put private in front of that property, and that will let the computer know that it's private, and then you will not be able to access that object or that property or that function directly by calling it like you would here. You would actually have to introduce a method that actually goes to get it, public method that goes to get it, kind of like this is doing. Or if it's completely private and you want no one to access it, well, they cannot programmatically access it. You can see it if you're able to open the code, but no one who's using that object can open the hood, look into the engine, if you will. That was a whole mouthful, but I hope that that was clear. Okay, a couple of other things about classes that I want to make sure that I get across. So sometimes when you're working with classes, you might come across the word instance. The only difference between a class and an object is that a class is more of a blueprint describing what is supposed to be in the object. So again, that's what this is. This is a blueprint describing the behavior, the look and feel of a particular class that we can use over and over again, okay? You're describing that to your computer so that when you create one, when you create a instance of this class, and there's that word instance, it becomes an object, a live object that you can access and you can tell to do particular things. So the difference, again, when you come across the word instance, realize that the word instance, like instance variables, the word instance is pretty much referring to the creation of the object. So a version of the object that's created in the program, and you can have several. And probably something else to know about classes is that actually we have been using classes all along in the JavaScript language. The JavaScript language has built-in classes. One of those classes, for example, is console. So earlier in the tutorial and at the very beginning, to keep things simple, I didn't explain what this console is. I'm probably still not going to get into a lot of detail. Just know that it's a instance of a class called the console that represents this little thing down here. What the console is supposed to do is to print content down in the terminal for you. So I'm telling this console to do something, to log or to say whatever content I'm providing. Another example of a built-in class is something like, let's say we create a variable called name string, and this is a variable that if I were to come down and log that, of course, the console being the object that it is with built-in stuff. By the way, this is probably a public method log. I have no idea what's going on underneath with the computer to make it print things in this little window here. So that's an example of what might be private and what might be public in the case of a console object. But anyway, coming back to this example here, if I were to log this name string, of course I get my name. Strings and other basic types like ints and arrays, other things that we have learned about in this tutorial, they're built in. They actually are built-in objects that JavaScript provides for us to be able to use, and it has a bunch of methods underneath it we can use for convenience. For example, this name string is an instance of an object, and I can tell it to do a bunch of other things. I also have access to properties like how long. This is length here. This is actually a built-in property, and I can use that to tell me how long this particular string is. So if I come back down here now and I say log the length of the string, so I'm accessing this property, this public property called length, I get 5, right? So that's how many characters are in here. The same with, I can tell this string to do other things, like there's a method in here called includes, which is going to end up giving me a boolean for a result here, right? Let's just do the same thing we did here for our notes here. There are other built-in methods for the other basic types, but I just wanted to show this to you just to let you know that there are actual objects, built-in objects that every single language provides for convenience, and you can use those built-in methods to do lots of cool things. Let me hopefully nail this home with showing you a few examples of objects in different languages. So in the lesson 7 folder, if you were to check this code out or check these notes out from Git, you'll see I have a car example.java, and this is an example of what an object looks like in Java. So Java, if you don't know about Java, it's a strong typed language, meaning unlike JavaScript itself, where you have you have these things here, you're setting variables and stuff, and JavaScript is trying to figure out on the fly what type of object this is. In languages like Java, you have to explicitly say what the object is, and so you have in here, we have a class that we're trying to make available to everyone. We have to say that this property, just like in our other class, this property is a type string. All of these properties are type string, and the same within our constructor here, and you'll see our constructor here is different. It doesn't actually have the word constructor, but Java knows that when it sees a method that is the same as the class here, it's going to say, hey, this is a constructor, and these are the properties that this constructor are taking, these string properties here. And when we construct the class, we're going to set these instance variables with these properties. Notice that we have the word public again out front as well. So this is the way that Java denotes public methods. You have to explicitly say that in Java. Just the same as if you have any private methods here, or CO2 injection method here, you have to say it's private. Languages like Java that are strongly typed also have some built-in things to know what this private method means. And it actually will not let users of this class, so if someone were to use this class in their code, they actually couldn't call this method directly. You can see it if you were able to open that class and look at it, but you couldn't call it directly because there's a private note here. So that's a cool feature built into strongly typed languages like Java. But as you can see, things are very similar. If you were to open up some Java code, this will look very similar to what you would see in JavaScript. Most of the concepts or paradigms are pretty much the same, except you have to be very explicit. But if we were to jump into Python, a Python class, it will look a little bit more toward the JavaScript. And that's because, as we discussed before, Python has the ability to use object orientation, but it's a little closer to JavaScript in nature, where things are dynamically typed. The compiler or the code as it's being ran kind of determines what's being put in there. So I don't explicitly say string, but if I were to put strings in here, it would know what to do. If I would put numbers in here, it would treat them the same. So this is a constructor in Python, which is this init function. So whenever this thing is created, it's going to run this init function, set things the way constructors do. It is our go beep function. This is the way we print things out in Python, as well as we can call other functions from here, from our other methods from here. Python, like JavaScript, has no idea what private and public is, but just like JavaScript, you can denote a private function just visibly, right? So you can give a visual indication for others who might be using these methods that they might not want to call these methods directly, because maybe they're a part of something that needs to be used in conjunction with another or what have you. But you'll see they have access to this method using this here. You don't want to mess with it directly, and there's probably a good reason for it. Folks, I've put a lot of time in distilling 10 years of experience down to very simple bites, tidbits, golden nuggets for you to nibble up. So if you like how I'm doing this, go ahead and like and subscribe to the channel and share this content with someone else who might be interested in learning how to code. And if you are ready, we're going to take our experience here at creating classes and talk about the next big piece in understanding object-oriented programming quickly, and that is something we're going to call inheritance.